Okay, so some people have issue with the double slit experiment and the single slit diffraction. So what we are going to do is that we will try to understand that how to solve the questions. I will not go in details again, because we have discussed it before. So I'll just put a contrast between the single slit diffraction and the double slit pattern, and we'll tell you how exactly to solve the problem easily. So let's take this. As this is Young's double slit experiment. First we'll talk about the double slit interference pattern, or YDSC. So this is the screen. We have a screen, and then we have like the slits. The slits are the small openings from the light would basically come. Now when we try to find out the location of the central maxima, the central maxima is right between the two slits, which is S1 and S2. So in the center, it comes here. This is the distance L, which is the screen separation. Okay. This I'm saying as small d, the distance between the two slits here. Wherever I'm trying to find the location on the screen, I will mark it as X, this point. So from the center to this point, I will treat it as X, and lambda is the wavelength of the light which we are using in this situation. Now, what happens, or try to understand it here, basically, that in the central location, like at this point, we will get a bright light. Why? I'm not gonna mess up the diagram. I'll simply say the light which is coming from here and the light which is coming from here, they are traveling equal path. So when they will meet, they will make constructive interference. So at this point there will be a maximum, that means there will be a bright line. Now when there will be a bright line, so after some time there will be a dark line as well. At what location, at what point there will be a dark point and everything, that we'll find out. Now try to understand this. This is the bright line. If I have to represent the brightness and I say that this particular graph, I'm going to present it like horizontally, and I say that this is the central point. So this point here and this point here is the same. Now here, this is the maximum. So if I say this is intensity, that means the brightness, intensity of the light. So at the center of the screen, you will see a brightness, intensity. Now, if there is something, a bright spot, in the left and right of that bright spot, the intensity will reduce. So this intensity will fall. It will reduce. The intensity reduces in the left and right. Now this, what meets here, this is the first dark line in the left side and in the right side. So there will be a dark line here, somewhere here, like exactly the same location, because the pattern is equal, like there's like completely uniform. So if it is here, then here as well, there would be a dark line, not brightness, darkness. So at this point there will be darkness. Then the brightness will start rising again. So then what will happen? The brightness will rise again. And then again darkness, and the pattern will continue. In practicality, the brightness reduces a little bit, but here we will assume that it is at the same throughout. Now at what location the brightness and the darkness and everything is. So for that, this is 0. Okay. The first location here, I will treat it as this location. It is given by lambda L by 2D. Lambda L by 2D. Here I am defining a term lambda L by D as beta. Some constant, it can be anything. So I am taking it as beta, lambda L by D. Lambda is the wavelength, L is the screen separation, D is the distance between the two slits. Now this is beta. Or this could be basically the position on the screen also. Wait. This is the location of the first dark line. Remember, here it is darkness, not brightness. So this is the minimum, lambda L by 2D. Or I can say that it is beta by 2, half. The next maxima, that means the first maxima after the central maxima, comes at a distance beta. That means every change is happening at half a distance. So if I say this point is maximum, this distance from here is equal to beta, which is lambda L by D. This is the maximum point. And if between two maximums there will be a minimum point will be lambda L by 2D. So if this distance they want, it is lambda L by 2D. This distance they want lambda L by 2D. if they want what is the width of the central maxima, so maxima is here and it is dying down in this region, so this is the width of the central maxima. How much it is? Lambda L by 2d, lambda L by 2d, that is beta by 2 plus beta by 2, or I can say that beta in total. So that is why this graph here represents the intensity or this pattern basically, where every maximum has a width beta. So if someone asks you, let's say in this situation, what is the location of the second maxima? Second maxima from central maxima. Central maxima. Second maxima from central maxima. Draw a line. This is 0. This is the central maxima. First maxima again will come at a distance beta. Second maxima will come at a distance beta again. So what is the distance of the central maxima? 2 beta. That is 2 lambda L by d. If they ask you what is the location of the second minima or second dark line from the central maxima, remember from central maxima. So this is the central maxima. First dark line is here in between. The second dark line will be here. So this distance is beta by 2. This distance is also beta. The distance between two dark lines or two bright lines is beta basically. That is lambda L by d. So beta by 2 plus beta, that is 3 beta by 2, which is 3 lambda L by 2d. That's the location. And accordingly you can find out. And that is why in the previous video, I have explained it, that how exactly you can locate it. So if I have to basically represent it again, I'll simply go as, this is the intensity curve. This is for the double slit, remember, intensity curve. And here we have the central maxima, then minima, then maxima again, and it keeps going. What is the separation or what is the distance of these positions? So this is 0. This total is beta and this is beta by 2. Half. Every half is beta by 2 and every full is complete beta. This is central maxima 0. This is the first minima after the central maxima. Minima means first dark line. First maxima after the central maxima. Second minima after the first bright line. Second maxima. If they ask you what is the location of the second maxima, so this is 0. From 0th maxima to the first maxima is beta. From the first maxima to the second maxima is also beta, so it is 2 beta. You can also find it in the left. The left and right, the pattern is same. So the width of all the maxima is same and the intensities of the brightness of all the maxima are equivalent. That is Young's double slit experiment or simple interference pattern. This is not the exact result, but yes, this is what exactly you gotta calculate or solve. So you can try those questions which were there with using the beta method. In case of single slit experiment or diffraction pattern, everything remains same. The only difference is now I have just one slit and I have to take the width of the slit. Instead of the separation between the two slits, that was small d, now we have the width of the slit. This is L, everything exactly the same. Here there will be maxima. The only difference is here what happens, the maxima widens up. Here the maxima widens up. Now when the maxima widens up, what happens? The central maxima has a width 2 times of beta, which is 2 lambda L by, instead of small d, now I have width, that is W. This is the width of the central maxima. Width of central maxima. And its intensity is more. Now the remaining maximas, what happens? Exactly the same. And it will keep going. Both sides, symmetrically. So if I have to represent it, horizontally if I have to represent it, this is the central maxima. This is from here to here is beta. From here to here is also beta. So the central maxima has a width 2 beta. Now, this is the first maxima, second maxima, third maxima, and so on. And here as well, first maxima, second maxima, third maxima, and so on. Now, this is beta, this as well is beta, and the width of all other maximas is also beta. The intensity falls, but the width remains same. Now, if they ask you, what is the location of the first maxima after central maxima? Central maxima. Now, this is the central maxima. First maxima after central maxima. So, this they want. They want this location. This much is beta. This much is half beta because the total is beta. So, beta by 2. So, what is the location of the first maxima? 3 beta by 2. That is 3 lambda L by W. If they ask you what is the location of the first dark line from the central line, first dark line is this. This is beta. That is lambda L by W. That is from the central maxima. Remember, what is the separation? What is the location of the second dark line? So this is lambda L by W. This is also lambda L by W. So 2 lambda L by W or 2 beta. So the only difference is that the pattern has shifted and the central maxima has taken more space. That's it. Everything else remains same. The intensity drops and you can solve using a simple component of beta or the simple equation lambda L by D, or instead of diffraction it is W. This is the width. If they ask you, we reduce the width, what happened to the width? Like we reduce the width of the slit, the hole. So then what happens? The central maxima will broaden because the width is at the bottom. So try solving these questions, like the questions which we have discussed before from that particular worksheet, and then solve it using this. The visualization of these graphs are very important. If you once get that, then solving the question becomes very easy. 0th, 1st, 2nd, and keep going. Accordingly, you can find it out.